to Taxonomy Online Mathematics. We are still continuing with our calculus. We are taking the rules of differentiation. In the previous video, we talked about differentiation from the first principle. Now we want to take the differentiation itself by rule. So if I have differentiation if I have any function in this form where n is a constant, then so if I have y equals to x exponent n, then my dy dx is going to be, the exponent is coming to multiply the whole function. This is the whole function, x exponent n. Then the power or the exponent is going to be reduced with 1. You reduce the value of the exponent with 1. So if, for example, we have y equals to x exponent 5, and I'm asked to differentiate this, this is going to be differentiation of this is going to be 5 is now coming to multiply the whole function. Then I reduce the exponent by 1. So it means final answer will be x exponent what? 4. That is the first rule of it. If I have differentiation of a exponent n, where a and n are all constant. So if y equals to a exponent n, then our dy dx or its differentiation is going to be hold your constant, multiply it with how we differentiate this. So exponent is multiplying the function, the exponent is reduced with 1. So let's take example, y equals to 3x exponent 4. What do? I hold the 3, multiply it with 4 is coming to multiply this function, then the exponent to be reduced with 1. So from here, 3, 4, 12. X, 4 minus 1 give us what? 3. So if you have to differentiate, this is what we get. The constant is hold, then we perform the differentiation of the function, then we multiply. Number 3, if I have also this function is the first one, a is the second one. Now, but if I have this whereby the x has no exponent, so if I have this, your dy dx is just going to be the value of a. The exponent is gone. Why? We know that this is going to be holding the constant. There is 1 here. Multiplying this with that 1, the 1 is multiplying the function 1. We reduce that with 1. So it means a times 1 is a. 1 minus 1 is 0. We know that any number raised to the power 0 is what? 1. So a times 1 is what? A. So if you have this, as for example, y equals to 3x, your dy dx is just going to be the value of 3. No other function attached to it. That is the third aspect. So similarly, if I have a differentiation of a constant, so let's say y equals to c as a constant. If I have this, now we know that if this is a constant, it means the x term is exponent 0. The x term will be exponent 0. So our dy dx is going to be hold the constant, which is c, multiply by the exponent. The exponent is multiplying the function, then we subtract 1 from it. You already know that if 0 is multiplying this, whatever I will get here doesn't matter. it will give me what? 0. So anytime you have y equals to a constant, then the dy dx is just going to be 0. If you differentiate a constant, you get 0. So that is the rules that we use in differentiation. If you don't want to use the first principle, so if I have y equals to, let's say you have 1 over x exponent 3, and I'm asked to differentiate, we can also employ the principles of indices. If I have 1 and I have a something dividing it, the power here becomes negative. So this is going to be rewritten as y equals to x exponent minus 3. So if this is a function, then your dy dx is just going to be, the exponent is coming to multiply the whole function, then we subtract 1 from it. So right away we have minus 3 x exponent minus 4. So we can present our answer this way, or we also know that this is minus. It was 1 as a numerator becomes exponent of negative. So if I have negative here, that can also be rewritten as what? 1 over negative 3 x exponent 4. But it doesn't matter what the negative will be. It could also be minus 1 over 3 exponent 4. Or better still, we said minus 1 over 3 exponent 4. So if you have this, even though it is in a fraction form, we can still convert it into a linear form with an exponent. Then we perform the differentiation. So that is all about differentiation. We will continue with it, with the sum and the product in the next episode.